Hey, my name is Zheng Liqiang. Welcome to this course. Next, we will introduce the randomization. This randomization sometimes is called random allocation. Randomization is a process of assigning clinical trial participants to treatment groups, and randomization gives each participant a known chance of being assigned to any of the groups. And successful randomization requires that group assessment cannot be predicted in advance. In clinical practice or nursing practice, research practice, there are the common types of randomization, including the simple randomization, block randomization, stratified randomization, and cluster randomization. And the simple randomization is a basic method to implement randomization, and you can use the following ways to implement the simple randomization. For example, the coin tossing for each trial participant. For example, the head to treatment and the opposite to control. And another way is the sequence of random numbers from scientist textbooks. And the third is a computer-generated sequence, and I will recommend you the computer-generated sequence is very important. It's very easy to implement the simple randomization. And the simple randomization is very simple and easy to implement, but some disadvantages. For example, at any point in time, there may be an imbalance in the number of subjects on each treatment. For example, with 20 numbers on two treatments, A and B, and the chance of 12 to 8 split or worse is approximately 19%. So the balance improves and the sample size increases. Thus, desirable to restrict randomization is to ensure balance throughout the trial. The block randomization is important in clinical trial and is very common used in the clinical trial. Block randomization is balanced with each block. The basic idea block randomization is first divide potential into n blocks of size 2n, and randomize each block such that n patients are allocated to A and n to B, and then choose the blocks randomly. For example, two treatments of A and B, and the block size of 4 is 4. And possible treatment allocations with each block are AABB, BBAA, or ABAB, and so on. And the block size depends on the number of treatments. It should be short enough to prevent imbalance, and not enough to prevent guessing allocations in trials. That's a way of, in clinical research practice, we implement the block randomization by computer-generated sequence numbers. Sometimes we use the SAS software. It is important. It is useful software. Yes, this is an example of a block randomization of design with three blocks, and every block, and the block size is 4, treatment of A and B. This block size depends on the number of treatments. The block size is not stated. You remember, it's not stated in the protocol, so that the clinical and the investigators are blind to the block size. And the block randomization will help us to ensure that the number of people in each group is close or equal, and it is very convenient for the accumulation of clinical cases, and it is suitable for multi-site trial. And you remember, the most commonly used method in clinical trials is block randomization. But if blocking is not masked in open-label trials, the sequence becomes somewhat predictable. For example, the block size is 4, then in each block, the B allocated to B, A, and B, and the last one must be A. So this is the disadvantage. of block randomization. Yes, the third method of randomization is the stratified randomization. Trial may not be valid if it is not well balanced across prognostic factors. And the stratified randomization means block with a block, for example, 3 age groups and 2 sex age groups. And for 6 patients in a block, and the total number of strata is 6. It produces comparable groups with regard to 30 characteristics, for example, sex, age, race, disease severity, and thus produce valid statistic tests. And you remember the stratified randomization of the statistic method is very complex. Yes, while you implement a stratified randomization, first you have to define the strata. Then randomization is performed with each stratum and usually blocked This is an example. Yes, the block size in stratified randomization should be relatively small to mitigate bias in small strata and to ensure that the overall imbalance is not great. And the stratified randomization with several strata predictability should not be a problem, and increase the number of stratification variables or increase the number of levels with strata lead to fewer patients per strata. In small sample size studies, sparse data in many cells defeats the purpose of stratification. Stratification factors should be used in the analysis, otherwise the overall test will be conservative. The fourth randomization is the cluster randomization. The cluster randomization has the similar process to other methods of randomization, for example, stratified or other simple randomization. The key point of cluster randomization is interact social units are randomized aside to different intervention groups. It is the communities or groups, but not the individual. Yes, the cluster randomization help us to avoid contamination. Contamination is a very common bias in clinical trials. This is an example of a cluster randomization trial. That is a informal school-based peer-led intervention for smoking prevention in adolescents. Yes, the randomization units is the schools, but not the individual. That is the groups of schools, not the individual. How to implement the randomization? There are standard ways. First is the random number tables, and another is the computer programs. But I will recommend you to implement the randomization using the computer random programs. Yes, the computer programs seems complex, but if you implement once, then you remember the programs. Next, it will be very easy. Yes, but if you will use the birth date or last digit of the medical record number and so on to implement the randomize, then it is not good. It's not right. So how to select the method of randomization? Yes, choose the optimal one method is based the appropriate to the sample size. And if I have to choose one, I will choose the block randomization in clinical trials and stratified by the site. This is a summary. For multi-site trials, the clinical should be a fact and gives replication of same experiment. Strictly speaking, an analysis should take the particular randomization process into account and usually ignored and thereby losing some sensitivity. Stratification can be used only to a limited extent, especially for small trials where it's the most useful, for example, merely empty or partly filled strand. Yes, if stratification is used, restricted randomization with strand must be used. These are major references. Thank you.